All right, here we go with the cylinder. Today we're going to talk about lateral area, surface area, and volume of this cylinder. First of all, what is it? Like a prism, a cylinder has two congruent and parallel bases. But while the bases of a prism are polygons, the bases of a cylinder are circles. And because these bases of our cylinder are circles, that means that instead of connecting the bases with a polygon like they did in the prism, the bases are connected by a curved surface. Now, if we were to take the cylinder apart and flatten out the curved surface, we can see that the cylinder really consists of three individual parts: the top base and the bottom base, which are made up of circles, and that curved surface, which when we flatten it out really ends up becoming a rectangle. To find the lateral area, we're really trying to find that curved surface that connects the two bases. Just like with the prism, lateral area does not include the area of those two bases. And the formula for finding the lateral area is to multiply 2 times pi times the radius of the cylinder times the height of your cylinder. Just like with the prism, surface area consists of the lateral area and that of the two bases. So the formula that we're going to use to find surface area is to take the lateral area and include with that the two bases. So capital B represents the area of that circular base. All right, why wait? Let's get started and have some fun. Sutherland Apple Company wants to produce some cans of apple juice. The can that they want to produce is 4 inches in diameter with a height of 6.5 inches. They want us to find the area of the plastic wrapper that needs to go around the outside of the can. Because we're not given a picture, the first thing that I'm going to do here is I'm going to draw a sketch of what our cylinder looks like. And again, I'm not real artistically inclined, but even I can draw a picture of a cylinder. I'm just going to go ahead and start by drawing those circular bases. And then I'm going to use my pen or my pencil to connect the circular bases, and I've got a nice little cylinder. They're not real forthright in asking us exactly what they want us to find. They don't come right out and say, find lateral surface area or find total surface area. Instead, they ask us to find the area of the plastic wrapper that goes around the outside of the can. You have to be smart enough to recognize that what they're really asking us to find here is lateral area. And the formula for finding lateral area of a cylinder, 2 times pi times r times h. So I'm going to go ahead and label now my pieces or my parts of the cylinder. This cylinder is 4 inches in diameter. Because I'm going to use radius here in this formula, instead of labeling a diameter of 4 inches, I'm simply going to label a radius of 2. The height, 6.5. So I'm now going to go plug everything that I know right into this formula. 2 times pi times 2 times 6.5. And now in my calculator, I'm going to remember that multiplication is commutative. I can change the order on multiplication, and it's not going to change my answer. So I can multiply these 4 things in any order I want. I'm going to go multiply the rational parts of them together. So the 2 times the 2 times the 6.5. And when I do that, I find that the lateral area of my cylinder ends up being 26 times pi. Area always measured in square units. Our units of measure here are inches, so square inches. And this brings us to the first big key idea for today. Unless they specify otherwise, all of our answers are going to be left in terms of pi. Now, if they said to round this to the nearest tenth of a square inch, I would get my calculator out, I would punch in 26 times pi, and I'd round it to the nearest tenth of a square inch. But because they don't specify, we're going to leave our answers in terms of pi. All right, at this point, if you have any questions about what we did, I'm going to ask that you leave or put them in the margin so that you can remember to ask about them when you come to class tomorrow. And with that said, I'm going to jump right into number 2, let the good times roll. This one is a little bit more forthright in that it comes right out and says, find the lateral area, find the surface area, here's this picture of the cylinder. So this one, I'm going to jump right in. Formula for finding the lateral area says to multiply 2 times pi times r times h. So our radius here from the picture is 2.8. Our height from the picture, 3.7. Once again, I'm going to grab my calculator. I'm going to punch in all the rational pieces. So I'm going to type in 2 times 2.8 times 3.7. And my friendly calculator tells me that's 20.72 pi square meters, or meters squared. So part 1, done. Now we've got to go find the surface area of this thing. Well, the surface area is going to be the area of the curved surface that makes up our lateral area. And in addition to that, it's also going to include the 2 circles that make up the bases here in this cylinder. To find the area of one of those bases, because our bases are really just circles, I need to know the formula for the area of a circle. So I don't care how you remember it. I use the little mnemonic fuzzy wuzzy was a bear, area is pi r squared. Yeah, I know it's dorky, but it gets the job done. However you remember your formula for the area of a circle, you need to make sure that you remember that formula. So 2.8 squared. I'm going to go ahead and type that into my calculator. So when I square 2.8, I end up with 7.84. So the area of one base now is 7.84 pi. Now I've got myself set up, so I just need to go back and plug into this formula. So lateral area was the 20 plus 0.72 pi. I've got 2 of those bases that each have an area of 7.84 pi. And now, going on in this formula, I have 2 different operations. I have the operation of addition, and I have the operation of multiplication. Aunt Sally says I have to multiply first. So I'm going to go ahead and multiply the 2 times the 7.84, and that ends up being 15.68. And there's still a pi attached to that. And now that I've done my multiplication, it's all okay to go ahead and do my addition and subtraction. So to that, I'm going to add the 20.72. So 36.4 square meters. Super. This one too, if you have any questions about it, jot yourself a little note in the margin so that you can remember to ask me about it when you come to class the next time. And let's jump right in and look at number 3. This is a really cool question. It says a company wants to produce a cylindrical can in such a way that the radius is 6.5 inches and the surface area is 592.12 square inches. To the nearest inch, what should they make the height of the can? What makes this question such a cool, interesting problem is that instead of giving us the dimensions of the cylinder and saying, hey, go find surface area or go find lateral area, in this case, they're telling us to work backwards. I'm still going to start with my cylindrical can. I'm still going to label all the dimensions in the can that I can. In this particular case, the radius of my can, or the radius of the circle that makes up the base of my can, is 6.5. They're asking us what the height of the can ought to be. I'm going to be not real original and call the height of our can h. Since we know the surface area, I'm going to go ahead and write down the formula for surface area. So surface area includes both lateral area and the 2 circular bases. And then I'm going to go plug in everything that I know. Since I know the surface area is 592.12, I'm going to plug in 592.12 for the surface area. Lateral area, I don't know, but I do know a formula for finding it. I know it's 2 times pi times the radius times the height. And while I don't know the area of the bases yet, I do know a formula for finding those. They're circles, and the formula for finding the area of a circle is area equals pi r squared. So what I've done is I've gone and plugged in or substituted in everything that I do know. I can take this one step farther now and go ahead and substitute in some actual numbers. So they tell us that the radius of our can is 6.5. The height of our can we don't know. But over here in finding the area of the base, I can go ahead and plug in here 6.5 again for the radius. I'm going to clean up the right-hand side of that equation and make it look a little bit more presentable. So in these terms that are being multiplied together, I can multiply the 2 times the 6.5 and get to 13 times the pi times the h. Over here, I'm going to do order of operations, and I'm going to do my exponents first and square the 6.5. And then once I square the 6.5, I'm going to go ahead and multiply that times the 2. So that ends up being 84.5 pi. Now the right-hand side of that equation looks a lot nicer than it did a few minutes ago, but it's still kind of ugly. So I'm going to take a minute and remind myself, what were we shooting for here? What were we aiming for? We want to find the height of the cylinder. We want to, in other words, solve that equation for h. So I'm going to go ahead and I'm going to undo the adding 84.5 pi to the right-hand side by subtracting 84.5 pi from both sides. So when I subtract 84.5 pi from the left side, I end up with 592.12. Subtract the 84.5 pi. When I subtract the 84.5 pi from the right side, I'm left with just 13 times pi times the height. And again, my goal or my mission was to get the h all by itself. Right now, I'm multiplying the h by 13 pi. So to undo multiplying by 13 pi, I'm going to divide both sides by 13 pi. So at this point, I've accomplished something pretty impressive. I've gotten the h all by itself on the right-hand side. On the left-hand side, I've got the 592.12 minus the 84.5 pi, all divided by 13 pi. That's kind of ugly looking on the left-hand side, but thankfully I've got a calculator that I can plug that into, and I'm going to take a minute and go ahead and get my calculator out. And in order to find the height of our cylinder, I'm simply going to type that whole mess that I have on the left-hand side of my equation right into the calculator. Alright, so I'm going to go to the home screen. Once I go home, I'm going to add a new document, add a calculator. In order to get that fraction in there, I'm going to hit this little button right here. Then I want the fraction, and I'm just going to type it right in there. 592.12, subtract 84.5 pi. The pi button is on the left-hand side of your calculator, right down near the bottom. And then in the denominator, I have 13 pi. Hit enter, and I now know that the height of my cylinder is about 7.99. And if I go back to the page, they wanted us to find that height to the nearest inch. So to the nearest inch, the height of our cylinder is going to be 8 inches. That's a tough one, and you have to remember some algebra from last year. But it's also kind of an interesting question, I think. All right, we need to now go take a look at volume. Remember that volume is the object or the space that a figure occupies. The way you're going to find volume of a cylinder is the same as you found volume of a prism. You're going to multiply the area of the base times the height of the cylinder. So that's kind of good because, again, it's the same as what you already know and can do from the prism. So in this fourth example now, they're asking us to find the volume of the cylinder. So again, my formula here says to take the area of the base, multiply it times the height. Our base is a circle. Formula for finding area of a circle is pi times r squared. So pi times 2.8 squared. Again, I'm going to get my calculator out. I'm going to square the 2.8. So 7.84 pi. I'm going to come back over here, plug that in. The height of my cylinder is the distance between the two circular bases, or 3.7. And just like with surface area, they didn't tell us what they want us to round to, so I'm just going to leave my answer here in terms of pi. So 29.008 times pi, and this is either going to be cubic meters or meters to the third. All right, this one too, if you have any questions about it, jot it down in the margin so that you can ask when you come back to class. Number 5 is a really interesting, intriguing question, and I'm not so sure that we can do it justice here in the last few minutes of our video, so I think what I'm going to do is leave off here. I am not going to leave you hanging forever though. When you come back to class the next time, we'll talk about number 5, but again, I would rather do it while you're fresh rather than do it now while you might be tired from everything that you've learned over the course of the last 16 minutes. So this one, again, you'll leave blank. We'll tackle it together when you come back to class the next time. As always, if you have questions, write them down in the margins so that you can ask about them, or better still, shoot me an email so that I'm prepared to answer them next time you come to class.